Good afternoon, everyone. I am Poonam Thopte, and I am from Computer Department of TSSM BSUR. And my topic name is the classification of thorax disease in chest X-ray images using deep learning framework. So, here are the outline: introduction, objective, literature survey, limitations, proposed system, mathematical model, algorithm, and conclusion. So, in introduction, the thorax or chest is also called as the upper layer of our trunk. So, mostly the rib cage, spine, and shoulder griddle keep it safe. The ridge cap is made up of lungs, hearts, and some organs, which all work together to feed, breathe, and pump blood to all part of our body. Chest pain is the most common reason for getting checked into the emergency room. When a chest pain comes, chest radiology or a chest X-ray is one of the common type of radiology test used to find out the what's wrong with the thorax. Sometimes a radiologist or a restorative inspector don't notice or identify what the important information or what is wrong with your thorax. So when these X-beams are not examined, the illness appearances are found. So lots of time, it takes lots of times. So in this paper, we show how to use a deep convolutional neural network, which is a CNN algorithm, to figure out what's wrong with your thorax. So the objective of our paper is to propose a deep CNN that collaboratively learns discriminative feature for CXR images classification, and to propose consonant to pay more attention to the disease correlated regions and preserve more discriminative features. And second is to propose the straighten the semantic dependencies of multi diseases features in the feature space with a spatial and channel encoding model. And another is to address the interclass sampling similarity problem in chest X-ray beams images, and we propose to train a consult net with a pairwise confusion strategy. So here is a literature survey. In the first paper title is multi-atlas brain paralyzation using sequence and excitation fully convolutional networks. The authors are Z Tank, X Louis, and other, and the publication year is 2020. And description: in this paper, author proposed a novel multi-atlas DLP method for brain paralyzation. And in this paper, the author used the FCN algorithm and sequence and excitation models, and it can be automatically and adaptively select and feature from the most relevant brain atlases to guide a paralyzation. The second paper which we are is high resolution encoder decoder networks for low contrast medical image segmentation. The authors are S. Zoe and DNA. The publication year of this paper is 2020. In this paper, the author claimed that it is keep connectors are not significant to relay find KZ borders in medical images, and a novel encoder decoder network with multiple scales of density connections, and across encrypty loss function and contour regression tasks are used in conjunction with these routes and improve the borders detection quality. The another paper is segmentation of MR brain images through hidden marquee random field and hybrid Mathwas algorithm. The authors are T Farms and the P Seri, and the publication year is 2020. In this paper, author says the using a new hidden Markov random fields and models and a new hybrid methodistic methods based on the cuckoo search and a particle SWAM optimization algorithm. So in this paper, the hybrid meta heuristic algorithm is implemented to increase the quality of seeking the solutions in the map and estimated of the HMRF model. And the another paper which we are referring is deep ranking for image zero shot multi-labeled classification. This paper is also published in 2020, and the author offers a deep regression model that utilizes the correlations in the intermediate semantic layer of the word vector to the accurately predict labels for the usual features. And the last paper of which we are referring is classic digits identification and localization with limited supervision. This paper is published in 2018. In this paper, author says it is visible to identify and locate disease at the same time using the same underlying model for all photos, and using both class information and limited location annotations. Our technique beats the comparable references baseline in both classification and localization tests. So the limitations of our project is it not detect all the features from our X-ray images, and it sometimes it may have a low accuracy. So this is the proposed system of the thorax disease system. So in that, first of all, we take a input image, nothing but our X-ray image or CT scan image. The X-ray image and CT scan image we use as an input, and after when we get input, we proceeded to the image processing. In image processing, in this step, we apply the image pre-processing methods like grayscale conversion, image noise removal, and for further processing. After that, we proceed to the image future extraction. In this step, we are applying the image threshold and edge detection methods to extract the cell nuclei from image and count that. So after that, we proceed to the image classification. In this step, we are applying image classification method and CNN algorithm, and after that we get our final result. So this is nothing but a mathematical model of our proposed system. In mathematical model, the thorax disease classification is as a set of IFO, where I is nothing but set of inputs. The input consists of set of images, which is nothing but X-ray images or our CT scan images from our data set. So, and after that, F is nothing but a set of functions. In that, F is equal to set of F1, F2, and F3, where F1 is image extraction, F2 is image pre-processing, F3 is feature extraction, and F4 is classification, and O is nothing but a thorax detection output. So here is algorithm of our system. In this, step 1 is select the data set. Step 2 is perform the pre-processing and feature selection. Step 3 is apply classification algorithm and which is CNN. And step 4 is calculate each feature FX value of input layer. Then step 5 is calculate bias class for each feature. And then In step 6, the future map is produced, and it goes to forward pass input layer. And in step 7, we calculate the convolution course in the future patterns. And in step 8, we produce some sample layer and feature values. And after that, we take a input derivation of the neuron in output layer uh, is back propagated. And in final step, we give the selected feature and classification results. So the conclusion of our paper is, here we show how to use the power of CNN and supervised multi-labeled classifier to solve the problem of thorax disease detection on CRX. This is a new method, combines these two things, and DenseNet 121 was used as a feature extractor, and different problem transformation methods like BR, LP, and CC have been used to solve a problem in different ways. On the chest X-ray 14 dataset, our method did a great job and was better than what already out there. These are the references which we are referring. Thank you.
You mentioned some limitations, right?
Yes, sir.
So what are the measures you are taking for that one?
Actually, sir, what happened? In medical terms, the X-rays and the CT scan images, they are quite complicated. So we can't say that it is 100% accurate. That's why we are focusing that, we are saying that it can't be.
Okay.
It has a low accuracy.
But nowadays we have advanced technologies. So the accuracies are more.
Yes, sir. Yes, sir. But it is totally depend on patient. So
Okay.
we can't play with patient health. So that's why we said.
Okay, right.
Thank you, sir.
Okay, so in the feature extraction, you say that you are extracting some features, right? And in the limitation, you are told that some features will not be extracted or will not be get identified. Can you tell me in your project which features you are extracting and which are not going to be identified?
Sorry, sir.
Which features you are going to be using for extracting from the X-ray image? Which features you are extracting?
Sir, we are using CNN algorithm. What happened when we are using CNN algorithm? In CNN algorithm, suppose there is one image, which is X-ray image. So in my paper, I'm having multiple images, which using multiple images, we are producing a single output. So in that output sorry, sir.
Okay.
Okay, thank you, Poonam, for
Thank
sharing
you.
your reflective knowledge with us. Okay.
Thank you. Thank you so much.